So in the final video, we're going to look at how to reduce heat transfer. So this is the learning objective today. Explain how insulation is used to reduce energy transfer in buildings this time. We've already looked at how to reduce it in the human body. Now we're going to look at reducing it into buildings to make buildings more energy efficient. Okay, so these are the heat losses from a typical house. So you lose about 25% here through the roof, 10% between your windows, 15% through your front door, and then 35% through your uninsulated walls, okay, and another 15% from underneath. Okay, so how can we reduce these heat losses? Okay, so just thinking about this, so for the doors, you could use something like a draft excluder, okay, just basically putting something in the gap between the floor and the door itself. For windows, you can use double glazing, we've already discussed that, or you can use very thick curtains. Okay, so double glazing is where you have glass and glass again, so two panes of glass, and inside there's going to be air, because we've already learnt that air is a very good insulator. Okay, then we have roof, okay, so loft insulation, so something called pink bats, for example, which is basically a way that you can put an insulator in the roof to stop heat loss occurring there. In the floor, you can use carpets, okay, because carpets are a very good insulator. Again, they keep the heat in. And in the walls, you can fill in the gaps, which are usually just air, with even better insulators, which suppress the transfer of heat energy. Okay, so you can also heat a room using a water radiator. Okay, so here we have a water radiator occurring, so on the side of the wall. Basically, it's a radiator which is filled with hot water. It radiates heat. Okay, so hot water heats the metal radiator by conduction. Okay, we've already looked at that. That's the first way it does it. So you basically have cold water, you slowly heat it up, and that metal begins to get hotter because the water is transferring its heat energy by conduction to the metal. Okay, and then that means the outer metal surface becomes hot, it gets in contact with the air, and therefore you have heat transfer by both conduction and radiation. And then the hot air circulates in a room by convection, which I've already looked at in the convection video. Okay, so this is how a vacuum flask essentially stops heat transfer. So it keeps hot things hot, like your tea, and cold things cold. So how does it work? Well, it works through conduction. Okay, so it basically there's a gap between the liquid, or the container holding the liquid, and the outside. Okay, and in that gap is a vacuum, and we already know that conduction cannot occur in a vacuum. You've also got the stopper, so no heat energy can escape from the top, and or you could also have a glass cork, and there's also air spaces, because again air is a very good insulator. From convection point of view, again, because we've got that vacuum, you don't have much convection, because convection doesn't happen in a vacuum, and the stopper means that in the trapped air spaces here, it can't move, it stays kind of hot air because it's got nowhere to go. And then by radiation, the wall of the thermos itself is silver, and we've already discussed how silver or shiny surfaces reduce heat transfer by radiation. Okay, so just to finish off, pausing the video and trying to fill in the gaps. Okay, so heat is the form of energy that travels from hot places to cold ones because of the temperature difference between the two places, and heat moves by conduction, convection, and radiation, and thermal energy is an alternative name for heat energy. And that kind of summarizes all you need to know for thermal heat energy transfer.